Another great example, I know many of you are interested in this, of using the scientific method in everyday life would be something like this.
A blue line.
Oh my gosh. What is it?
What is it?
It's a giant blue string.
Oh my gosh. Oh, it's Mario.
So, do you use the scientific method when you're playing video games?
Yeah.
How? Yeah, you have to figure out how am I going to beat this boss on this level, and you may try out different things, try and smash that. Is it working? No. So what do you have to do? Try another method. Maybe hit its tail. Uh-oh.
It gets mad.
It's mad. All right. So again, select all your little power-ups and stuff. If you're gonna have to beat this thing eventually, you're gonna have a hypothesis about how you slay this thing. What is it? Okay. You try that. Hit its tail again. Does that work? But now what? It's mad. All right. Wait. So let's chase it. Am I gonna ever catch it? What's your hypothesis? How am I gonna catch those things too fast?
Wait, you're actually
Cut it off.
Oh, so like turn around?
No. Go in front of it. Turn in front of it.
Here, I'll go the other way. Yeah. All right. So, successful?
yes.
All right. Now what?
Something. I don't know what's happening.
Man. Successful? What's my observation? Did it work?
It's dead.
I guess.
Yes. Concluded. So, how big is my Wii controller?
That was not dead. It's a video.
All right, I'm not going to play anymore because it's going to take too long. Dino Piranha are the best. Okay. So, yes, we use the scientific method all the time. Playing video games, baking things, playing sports. All right, so let's talk a little bit further about scientific method. Please take out your notepad. We're going to do a few more things. So do you guys remember yesterday we talked about two experiments? The plant experiment and the mouse experiment. You remember those?
Yes.
All right. Because we're going to refer back to those today. So you're taking out your yellow packet, you're a couple pages in. Now, when we set up an experiment, we talk about something called the variables. And when we talk about the variables, we're talking about different factors, different aspects of our experiment. You know, have you guys talked about these before in elementary school? The independent variable, the dependent variable. How many people are familiar with these terms? No. Okay. All right. So we're going to talk about these, and you're going to have to understand what they mean and be able to identify, in this experiment, what was the independent variable, what was the dependent variable, and so on. So first with the independent variable. In an experiment, the independent variable is the one thing that you change in your experiment, the one thing you alter or modify between your groups. So do you guys remember the mouse experiment we talked about, the vitamin C? So in that experiment, what was different about my two cages of mice? How did I treat them differently? Natalia?
There is different amount of vitamin C.
Yeah, they each got different amounts of vitamin C. In my experiment, that was my independent variable. That was the one thing I made different between my groups. You could think of it as kind of the cause in your experiment. We thought vitamin C might cause the mice to grow larger. All right, what about the size of the cage in that experiment? What should that be? Kai? Not? Yeah, so what, would it be the same between my two groups? How about the type of food they were getting?
The same.
How about the amount of water?
The same.
The age of the mice?
The same.
Everything should be the same between those groups, except for vitamin C or not. So all those other things you guys were just naming, or I was naming, and were the same, we call those variables that were held constant. They were things I made sure were the same in my two groups. So the vitamin C was different, but all those other factors, they were the same. They were the variables held constant. If you think back to my plant experiment, what was wrong with it the way it was originally set up? When I first showed it to you, there was a problem with that experiment. What was the problem? Alexander?
Nothing was the same. They were the same. The Y was the same.
Yeah, there were too many what? What term would we use now that we just talked about? Natalia? Yeah, there were several independent variables. There were several things that were different in my two plants, and that's not a good experiment. In a good experiment, how many things should be different? Just one. There must only be one independent variable in a good experiment. Okay? The plant experiment at first had too many things different. So how did we change all those other factors to make it a better experiment? What did we do? Hayden?
We made everything but the plant's legs the same.
Yeah, we made the same water, same type of plant, same time period, and then it was a better experiment. So we made sure to hold those other variables constant. And then the last type of variable is something called the dependent variable. The dependent variable in your experiment, it's the data you're collecting. Okay, the data that you collect. You could think of it as the results of your experiment. And you don't know it ahead of time. You are figuring it out as your experiment's going along, as you're measuring it. So if you think of the independent variable as the cause, what is the dependent variable? The effect. It's kind of like the results of your experiment is the dependent variable. So in our plant experiment, what was the dependent variable? What were the results that we were looking at as our experiment went along? Jordan?
There were one green ones that had more water and one.
Okay, you're giving me a little too much. But what did we measure?
The plant size.
The height of the plant. That was the data we collected. Those are our results. That would have been the dependent variable in that experiment. How about in our mouse experiment? What was our dependent variable in that experiment? Casey?
If mice gain weight and didn't too much.
Okay, you're giving me just a little too much. So what did we measure? The weight of the mice. So when I ask you for the dependent variable, you don't need to tell me the results. Just tell me what was measured. The weight of the mice. Good. Okay. Now to help remember these, what I tell people sometimes is the I in independent variable looks like what number? 1. Because there's only one independent variable. It's the one thing different between your groups. The D in the dependent variable stands for data, because it's the data you're collecting in your experiment. So that might help you to remember those variables. Okay. Think back to my little sandwich experiment. What was the independent variable in that experiment? What's the one thing different between my groups? Felice?
The tomato?
Sort of. What about the tomatoes?
Because they were kind of soggy. Well, the bread was.
Yep.
And
But I had tomatoes in my sandwich both days, but what was different about it?
it was like on top of the two barriers.
Yeah, so it's the what layer I put the tomatoes in. That's what was different in my two sandwiches. How about what were some variables I would have to hold constant in that experiment? My sandwich experiment. Kai?
Same type of bread, cheese, and lettuce.
Yeah, all the same ingredients. Good. And it should be the same amounts. And I should like put it in the same bag or whatever I used to carry it. And then what was my dependent variable? What data did I collect here in this experiment? Madeline?
Like how it would turn out.
Yeah. How soggy was the bread? That would be my dependent variable. Okay, so that's what these variables are. All right, another thing we think about is in a good experiment. So let me ask you this. You remember our mouse experiment? Could I have just had one cage of mice
No.
and give them extra vitamin C and see how big they got?
No.
Why? Why would that not be a proper experiment? Okay?
Wait, was it that you give them both vitamin C?
I just have one cage. I give them the vitamin C and I'm going to see how big they get.
Because one might get more than the other.
No, not necessarily because of that. Okay, Miranda?
Because you don't have anything to compare it to.
Yeah. So if I have my mice in the cage and I see how big they are, well, is that bigger than they would have been? I don't know. Bigger, smaller? I have nothing to compare them to. So we always need two groups. And we have a name for those groups. One is called the control group, and one is called the experimental group. The experimental group, sort of the name tells you, it's the one when you change something. You've altered it. You switched the independent variable in some way. It's the group you're experimenting on. So what do you do with the control group? Which one is that? Control group. Avery?
The group of mice that doesn't get experiment.
Yeah, so in general though, what would I say? What do we do with the control group? Alexander?
Collected data from that.
Well, you collect data from both of them. Kai?
Will you have it have the variables all constant, and they have like everything that it normally needs to have without anything extra?
Yeah, so I don't change that independent variable.
Yeah.
I keep it basically under, we would call it maybe normal conditions. It's like a test run we're going to use to compare it. So I didn't change the independent variable. I didn't give them extra vitamin C. That's the control group. And we always have to have a control group because otherwise you have nothing to compare them to. So we sometimes say we treat them normally. They're under normal conditions. That's the control and the experimental group. One is just for comparison, and the other we're changing something. All right, so let's just talk a little bit further about hypothesis.
Wait, we didn't finish.
Still working. So what is our new and improved definition of a hypothesis? New and improved definition. Mia? About what? It's a prediction you make about something specific. Who can give me some more? Alexander? Yeah, prediction about your experiment, about how you think the experiment's going to turn out, what you think is going to happen. That's what your hypothesis is, what you think will happen. All right, so it's a prediction. It has to be something testable. It's an explanation we can test using what? Using an experiment. It has to be testable using an experiment. And often we write it as an if-then statement. So it's what you think is going to happen in your experiment. So some example, if you turn on out all the lights, you will fall asleep faster. Okay, it's a prediction. Could you test that? Sure.
Please.
No, we're not going to go to sleep now. If you eat only fast food, then you will gain weight. Could we test that?
Yes.
Has anybody ever tested that?
No. Yes. Never.
Have you ever seen the movie Super Size Me?
Yeah.
Yeah, that's what he did. It's 30 days, ate only McDonald's.
Isn't there somebody who ate only fast food and then lost the weight?
Probably. That's what you eat. So a good hypothesis, first of all, has to be testable. It's never a question. It's always a sentence, a prediction. Okay? And it's based on research. You don't just sort of guess randomly. Usually it should be based on research. And that's why you guys always call it what? Not a guess, not a random guess, but an educated guess. Because you have some background information about this topic. So let's look at just some examples. You guys don't have this slide, right? Oh, do you?
I have more examples.
Oh, you don't have the regular? All right. So let's just do this together. Don't worry, you don't have to write anything down. So when we write a hypothesis as an if-then, if something, then something, the if part,
Six something.
oh, it's the exact same?
Yeah, it just
Oh,
a
okay.
different kind of.
Oh, okay. So, in your hypothesis, you have your independent and your dependent variable. So here, for example, if a plant receives fertilizer, then it will grow larger. That's a hypothesis. We can test that. In that experiment, what would the independent variable be? If we were going to do that experiment, what would the independent variable be, Captain?
One who received fertilizer.
One would get fertilizer, one would not. Yeah, the fertilizer is the independent variable. What would the dependent variable be? What would we measure? What data would we collect in this experiment? Aiden?
The plant's size.
The size of the plant, the growth of the plant. So you see my hypothesis contains both my independent variable in the if part, and it contains my dependent variable in the then. How about this one? If I put fenders on my bike, then they will keep the rider cleaner. You know what fenders are? Those little thing like over your tires so you don't get like mud sprayed all over your back. All right. What would the independent variable be in that experiment? Kai? Yeah, having fenders on your bike or not. And our dependent variable, what would we be looking at? What data would we collect here? Jordan?
If it will keep getting lighter sooner,
So what would we be measuring? Just give me a little less.
the lighters.
Yeah, the cleanliness of the rider. If I study more, I will receive better grades. What's the independent variable, Kaya? Yeah, studying. What's the dependent variable, Kaya? Yeah, the grades a person would get. So when we write our hypothesis like this, it's easy to figure out what the independent and dependent variable is. If I eat more vegetables, I'll lose weight faster. Again, eating the vegetables is independent, the weight is the dependent. If I wear a wetsuit, I'll be able to swim in cold water longer. Again, you see the pattern here. I don't need to go over all of these. Okay, so the independent variable is always in the if part. The dependent variable is always in the then part. All right, one more slide here. You might have to skip ahead one page, or go back one. The chicken farmer. So this is going to be similar to your homework. You're going to read about several experiments, and then have to figure out in those experiments what was the independent variable, what was the dependent variable, what was the control group, experimental group. So in this case, a farmer wanted to know if music would make his chickens lay larger eggs. So he took two groups of chickens, placed one group in a pen with music, and the other group was placed in a pen with no music. All right? So if he did this experiment, who could tell me what is the independent variable in this experiment? Independent variable, right?
Larger eggs?
No, independent, the one thing that's different between his groups. Go ahead, Ryan.
The pen with no music?
Well, sort of.
It's music.
Music. What's different? So when you ask the independent, we're saying, okay, well, what's different between the groups? It's music.
Mm-hmm.
Some have music, some don't. What would the dependent variable be in this experiment? The data being collected, the results. Alexandra?
Chickens with music will lay larger eggs.
Okay, so a little less. What data are they collecting?
Bless you. Thank you. They lay larger eggs.
Well, close, but what would they measure? The
Size.
size of the eggs, yes. Size of the eggs. Okay, now one of these is the control group.
Do I have to ask her for that?
Yeah, usually.
Okay.
Yeah. Kai, what's the control group in this experiment?
Group that has no independent variable. The independent variable does not change.
So which one would it be?
It would be the one without music.
Yeah, the pen with no music playing. They're just being treated normally. We didn't change the independent variable. So what would we call the one with the music playing? Somebody else, raise your hand if you could tell me. What's the one with the music playing called? Some people I didn't hear from today. Aaron?
The experimental group?
Yeah, the other one would be the experimental group, the one with the music playing. So what are some variables this farmer should have to hold constant to make this a good experiment?
When should we throw pen from?
Catherine? Yeah, how much food the chickens are getting. That should be the same. How about something else? What else should be the same? A variable held constant. Aaron?
The same pen?
Same type of pen. Kai?
Same type of bedding.
Same type of bedding material. Avery?
The same time chickens are in and out of the pen?
Yeah, all those things. We could go on and on with a long list here. All those things should be held constant. Same type of coop, same age of chicken, whatever. You don't need to have these exact ones. But all of those other factors, we want just one single thing different. Whether or not they're hearing music. Okay, any questions about what we've covered today? So control experimental group and the variables. Tomorrow we'll actually do an experiment using some of these things.